In this video we'll look at factorising using double brackets. So in previous videos we looked at factorising with single brackets and they took the form in green there, ax squared plus bx. So an example of that would be 6x squared plus 8x, and what we would do is look for common factors. It would be in this case 2x. We would open up a bracket and 2x times by what gives you 6x squared? Well, it will be 3x. And times by 4 to get you 8x. So that's single bracket factorization. But in this video it's a bit different, because now it takes the form ax squared plus bx plus c. So that now there's a constant c at the end there. So for example, x squared plus 7x plus 10. So when there's a constant at the end there, we have to use double bracket factorization. So let's carry on with this example. So the first thing we're going to do is open up the two brackets. And I can straight away write in x into both those brackets. The reason I know I can do that is to get this x squared term here, I'm going to get that using x times by x. Now the only thing to figure out to do is what number goes here and what number goes here. And this is the tricky part. So to figure out what those two numbers will be, first we need to think about two numbers which will multiply to give you plus 10. So I'll list out those pairs here. So first we can have 1 and 10. Second we can have 2 and 5. Third, don't forget the negative, so we have minus 1 and minus 10. And fourth, we could have minus 2 and minus 5. Okay, so those are our four pairs of numbers. The third thing we think about is what pair of numbers add to give you plus 7, add to give you that term in front of the x. So we look at the pair of numbers which multiply to give plus 10, and we figure out which one of those pairs add to give you plus 7, and the only one that works is plus 2 and plus 5. So I can straight away write in x plus 2 and x plus 5. And now we have factorised that expression in blue to give x plus 2, x plus 5. And the way we know we're right is we could then expand those brackets. So x times by x, x squared, x times by 5, 5x, x times by 2, 2x, and 2 times by 5, 10. So we can see here that those two numbers have to multiply to give plus 10, and when we collect like terms here, we add up those two things. So we add up the two numbers inside the brackets to give you that 7 term. So when we collect like terms, it will be x squared plus 7x plus 10. So what we did, we wrote x in both brackets. We thought about a pair of numbers which multiply to give you that constant term, and added to give you that middle x term. Okay, so a quick tip here. If this constant term at the end is a positive number, we know both the numbers in the brackets will be positive, or we know both the numbers in the brackets will be negative. The reason we know that is because when we multiply two positives, we get a positive, and when we multiply two negatives, we get a positive. So if this c term is positive, we would have two positives, or we would have two negatives. And likewise, if this c term at the end here was negative, we have to have one of each. So a positive and a negative, which will give you a negative, or a negative and a positive, which will give you a negative. So that's a quick tip on thinking about how you're going to generate those two numbers. So here's our expression, x squared plus 4x minus 5. So thinking about the last example, we would open up our two brackets, and straight away I would write in my x's. Okay, the last slide tells us if this n term here is negative, it means we have a positive and a negative. So let's list out the pairs of numbers which multiply to give you minus 5. Okay, so we'll have minus 5 and plus 1. We could also have minus 1 and plus 5. Okay, so those are our two and only pairs of numbers which multiply to give minus 5. The third thing we think about is of those pairs, which pair as to give you positive 4. And you'll see of those pairs, this bottom pair here of negative 1 and negative 5 is the only one that does that. So I can write in x take away 1 and x plus 5. So now we've factorised. If we expanded the brackets, you'd get x squared minus x plus 5x minus 5, collecting like terms, x squared plus 4x minus 5. So that's our way of checking that we've factorised correctly. And finally, last example, x squared minus 5x plus 6. So straight away again, because it takes the form ax squared plus bx plus c, I can open up my double brackets and put in an x into each bracket. Step 2, think about a pair of numbers and multiply to give you plus 6. So I'll write out 1 and 6, 2 and 3, minus 1, minus 6, minus 2, minus 3. Okay, step 3, which pair of those numbers add to give you a negative 5? Well, of those pairs, the only one that works will be the pair of minus 2 and minus 3. So I can write in x minus 2 and x minus 3. And once again, we can check we're correct by expanding those brackets. So x times by x squared, x times by minus 3, minus 3x, x times by minus 2, minus 2x, minus 2 times by minus 3 is plus 6. Collect like terms, x squared minus 5x plus 6. So it works, and therefore we've correctly factorised this expression here to make x minus 2 and x minus 3.